Hi, this is Team 2 under Dr. Fresh and Mommy, and this is Summer Kim.
I'm Srujan Gupta.
And I'm Ida Wang.
So our goal is to make it easier to understand complex chemical reactions, and our task was developing a 3D VR environment that visualizes different graphs of different molecules that will be generated using our Python code. And in our 3D space, users can interact with graphs and change values for each input and see the different results and access to each value and each specific data plot. So first of all, A-frame is a library that within HTML, so where we can write it and run it on the web. So it's we create a web VR environment, and so we basically write HTML and Python server, and we connect those two. So this is the basic structure of our project. So we have a main Python file which is called view.py, and this file creates a development server and technically connects all the HTML and JavaScript files together. So first of all, what we have to do is run view.py on the terminal, and it's going to make a development server, and then it's going to run a function called home, and that home function is going to put input.html on the website. On the web, and the input.html is going to get the input from the user, and using the user data.ph.py is going to do the calculation, send it back to the view.py, and it's going to run the result function, which will run index.html, which is our actual VR environment. And this index.html is connected to our JavaScript file called functions, and these functions connect our index.html and data.ph.py. So whenever user changes the value, it redo the calculation and generate the new graph. And all those JavaScript files and SF files are stored in the folder called static, and that's how a Python development server access those values or those files. So this is a brief description of how data.ph and Flask works. So data.ph.py file does all the calculation for our graph and generates for each molecules, and it also gives the maximum minimum value for each pH measures and concentration, which helps us to build the graph in our VR environment. And it gets a different type of inputs, which is a molecule name, the beta value, initial concentration, and the concentration increment, which is gonna help us calculate the pH measure. And then also we use the Python library called Flask to establish the development server and this allows us to connect Python files and HTML file and use different assets.
So each of our graphs generates about 1,000 data points, and there's 5 graphs, so 5,000 data points. And we use those 1,000 data points to show the exact curves of the graph or the form of the graph. But some of the graphs do end up having some very small values, like the graph in the top right-hand corner. So we added a button called the Show Trend button, which then allows us to show the curve or the form of the graph by changing the scale. So that changed curve or form is shown in the bottom right-hand corner. And because A-frame doesn't have any graphing tools, we had to create our own axes as well and create most of the graphs tools that are seen here. You can also view the individual data points within each graph. So if you zoom in on a certain portion of the graph, then you can see the exact values of that data point right there. Sunny, can you go to the next graph, or the next slide? So the user can manipulate the graphs. So the user has the ability to add in 7 different inputs when the file is initially run. These inputs are shown in the top left-hand picture. The molecules, log beta values, initial concentration, other concentration added. After that, then once they've changed the initial values, then they can also change the values within the actual environment through our keyboard and also our numpad that we have shown in the bottom left-hand picture. The graphs can also be manipulated via sliders. So we have the slider right above the keyboard that can show a certain portion of the graph if you just wanted to see, for example, the first 250 data points or something like that. So now I'm going to screen share and just show the features of our project real quick. Yeah, so I'm going to be now showing the actual code we have running. So this is what the initial screen ends up looking like. And we have some default values for the enter molecules and for first log beta. For example, log beta is 0, and the default value for molecules is A and H. So you can just click submit directly, and the program will run just fine without filling out any of it. So as I talked about earlier in the presentation, there's the actual view of individual points like we have right here. So you can see the exact value at each point. And then because some of the values are very, very small, you can come over here and hit the show trend button. And that will allow you to see the exact trend of the data. And you can just come back here, hit the show datas, and you can see the original data. And then from there, we also can change the actual values of the graphs itself. So if I wanted to change that default value of 0 for the first beta, I can change that to something like 5. And then come over here and hit enter. And now all the graphs have changed. And the show trend button still does work with this, as well as show data. So there's that. And then we can come over here and we have slider manipulation. So if I want to see only 50% of the data, I can come over here. And because there a large portion of the data is clumped up right here, even though it doesn't look like 50% initially, because of the clumps of data, this is actually 50% of the data. And then if I want to see all of the data again, I can just click the end of the slider. And now you see all of the data. And so the slider is just a very convenient tool to play around with. So yeah, that's our A-frame environment. The keyboard and numpad, all of that is stuff that we designed and made ourselves. And so alongside these axes, like I mentioned earlier, the slider we did get from another library, but we had to add some of our own custom stuff in order to actually make it work with our project. But yeah, I'm gonna pass this on to Kathy now.
So this project does not only plays an important role in this research, but it also has a broader impact on how this can be used in the real world. For our next steps, first, we're gonna refine UI design to be more pleasing for users because the current UI is more about features rather than user focus. Next is that we're gonna have it hosted off the Nautilus cluster rather than just running it locally off our machines. And we're also gonna integrate Team 1's work into it. So can you change to the next slide? Okay, to wrap it up, we look to create a tool to help understand the complex chemical reactions. And we created an easily manipulated 3D environment to show these reactions. And this environment also allows the user to test different input values. And the next step is gonna integrate the code from other team to our environment, as well as clean up our UI. And that's it. Thanks for listening.